Okay, so we're going to continue on with this idea of solving systems via elimination method. So we have a couple previous concepts we need to go over, and we have one new key concept that we need to talk about. So the previous concepts are, the first one is the addition property of opposites, which basically just simply states that if I take a number, any number, okay, and it's positive, and I add to it its negative value, that I will effectively create 0. So just a quick example of this would be, would be 4 plus negative 4 equals 0. So using it with numbers, you could pick any number here, they just need to be opposites. Subtraction property of equals. So basically what I'm saying to you is that I am going to subtract equivalent values from one another. So therefore, if I take A and I subtract A from itself, I will effectively get 0. So an example of this would be, say, like 5 minus 5 equals 0. And the new property we're now going to talk about. So here's the new concept. This is the one that you need to know for basically this one today. So new concept, and we're going to couple it with something else. So the first one is here, multiplication property, which basically states that if A equals B, then if I introduce multiplication property, which means that if I take A and I multiply it by some number, C, then that is equal to whatever that same value of B times C would be. So basically what I'm saying to you is this, that if I have two things that I'm claiming are to be equal, that if I multiply one thing by A, that I must multiply the other thing, or must multiply the other thing by the same value so that they stay equal. And that's all the multiplication property states. So let's talk about how does this relate and how are we going to use this? So let's go back and talk about something. So given the system of A1 times X plus B1 times Y equals C1, and A2 times X plus B2 times Y equals C2, to use the elimination method, we must satisfy the condition that, okay, and we talked about this before, that A1 must be equal to A2, or B1 must be equal to B2. So we need to have that happen to be able to use the elimination. So what do we do if that A1 does not equal A2? So that little slash through here means does not. Okay, does not equal. All right. And what do we do? All right, also if B1 does not equal, okay, does not equal B2. What do? All right. Well, we utilize the multiplication property. All right. Of equality combined with the mathematical concept of LCM. And if you don't remember what LCM stands for, it stands for least common multiple. So we're going to combine the two. So first things first, all right, before we do anything, what we need to actually do is review what the least common multiple is. So there are two methods to find the least common multiple. One of them is our mental math skills of our times tables to figure out the smallest number. So if you have good multiplication skills, meaning you can do all of your times tables basically up to 10. So if you can do all of your times tables from 1 to 10, like things like 6 times 7 and go that's 42 and not have a problem, and you don't have to really struggle to think about your multiples, then you can use mental math for a lot of these, all right? But if you're a person who is not very good with your mental math skills, you need a way to do this. And the way to do this is with a formula. And this formula, I'll explain what it means in a second. But this formula basically states that you will take the two numbers, okay? So the LCM formula, you will take the two numbers, A1 and A2, you will multiply them. And then after you multiply them, you will divide them by the largest number that goes into them. So for instance, that if you took A1 times A2, right, and you found that 5 went into both of those, and that was the largest thing, you couldn't divide it out by anything larger than 5, you would simply divide the multiplication process by 5. So let's practice a couple of these, okay? So when we practice a couple of these, we take a look at this. So determine the LCM of the following sets of numbers. So I want to know what is the LCM of 5 and 4. And the reason I want to know what the LCM of 5 and 4 is so I can figure out what I can turn both the A's into or both the B's into. So your mental math process. So I will show you what you would do mentally. The mental math process would start like this. You would take 5. And what you would do is you would list out your 5s. And what you will do is you'll go 5, 10, 15, 20, 25, 30. All right, and what I like to do, if I'm using the LCM, what I will do is I will not list out my other times tables. What I will do is I will divide every number in this list. So I will start dividing every number in the times tables of 5. Now be very careful. You always use the larger number. So I will not use 4. So I will always write the times table of the larger number between the two of, in this case, 5 and 4. So 5 is the larger, so I'm going to write the times tables of 5. So 5, 10, 15, 20, 25, 30. And what I'm going to do is I'm going to start dividing them all by 4. And what I am looking for is the first number that goes in evenly. So 5 divided by 4 doesn't go in evenly. Does 4 go into 10 evenly? No. Does 4 go into 5 evenly? No. Does 4 go into 20 evenly? And the answer is yes. So since 4 goes into 20, the LCM is equivalent to 20. Okay, so it is the smallest number, the first number in the times tables of 5 that 4 actually goes into. So 4 can also create 20. Now, using the formula. So the formula will go like this. You will take a look at the LCM, and what you will do is you'll multiply the two numbers. You'll take 5 times 4. So multiply them, and you'll divide that by what is the largest number you can divide 5 and 4 by. Well, you can't divide, and you'll start with the smallest, right? Start with 1. Can you divide 5 by 1? Yes. Can you divide 4 by 1? Yes. Okay, can you divide 5 by 2? No. 4 by 2? No. 3 by, nope. Okay, so what I'm getting at is you're choosing numbers that are smaller than the two that are there, okay? So 5 and 4, the largest number that goes into 5 and 4 is 1. So now you just simplify the fraction. 5 times 4 is 20. 20 divided by 1 is 20. So we get to the same thing, okay, same LCM, one way using a formula, the other way using a mental math process. So on the B. So if you need to copy that now. Pause the video and copy. But on to B. So here we go, mental math process. So again, of the two numbers, I always take the larger. So between 6 and 10, 10 is larger, so what I will do is I will simply go like this. I will list out the multiples of 10. And I will go, okay, 10. And then I'll go 20. And then I'll go 30. And then I'll go 40. And I'll go 50. And then I'll go 60. Yes? And what I will start doing is I will start dividing them by 6. So I will take the 10, and I will divide it by 6. Divide by 6. Divide by 6, right? I'm just going to write 6 under all of them. And what I'm then going to do is figure out which one is the first one that I get a whole number when I divide them. So if you're using a calculator to do this because you don't know your times tables, right? You can still do this process, but you just need to do it with your calculator. So here we go. 10 divided by 6, no, doesn't work. 20 divided by 6, not a whole number. 30 divided by 6, yes, you get 5. So the LCM is 30. Okay, so the LCM is going to be the first number in the 10 times tables that 6 goes into. So the LCM is 30. So that's method 1, using the formula. So when I use the formula states just simply multiply the two numbers. So 6 times 10. And what you're going to divide it by is the largest number that goes into 6 and 10. So what can I divide 6 by that I can also divide 10 by? And I'm looking for the largest number. And that largest number happens to be 2. So here we go. 6 times 10 is 60. 60 divided by 2 is 30. Okay? So now if you're using a calculator, you can literally type this entire statement into the calculator and it will give you that answer. So when you use the formula, okay? Anyhow, so if you like that, copy that one down. So at this point, you should be trying to make a decision of which one you like because you're going to have to apply one of these to a problem in a second. So the mental math process, here we go. I take the larger of the two. So the larger between 3 and 9 is 9. And I'm going to write the 9 times table. So 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36, right? Dot, dot, dot. So I put the dot, dot, dot. I'll usually do up to 4 first, and then I'll check if the number goes into it. So what I do is I start dividing by the 3. So divide by 3. Well, boom, I'm done. 9 divided by 3 is 3. The LCM is 9. I'm done. LCM is 9. Okay? Using the formula, you will take 3, multiply it by 9, and then you'll ask yourself, what is the largest number you can divide 3 and 9 by? So I can divide 3 by itself. Every number can be divided by itself, so be careful about that, right? So 3 divided by 3 and 9 divided by 3. So I divide this by 3. So 9 times 3 is 27. 27 divided by 3 is 9. Okay, so the LCM equals 9. So these are two methods that you can use that will very quickly get you the LCM. All right, so let's talk about why we do this LCM and how we're going to apply it and what it's going to look like when we talk about problems of elimination. So let's take a look at a problem. The very first question you should ask yourself on every system, no matter whatever the system may be, whether you know anything about it or not, you should ask yourself, does A1 equal A2 or does B1 equal B2? Yes or no? So in this case, A1, so the A's, so the numbers with X, do not equal each other. The numbers with Y don't equal each other. So what I now need to do, okay, is the answer to this one is no. Okay, no, they don't equal each other. So since neither A's or B's, okay, are equal, we must find their LCM and convert using the multiplication property. So, step one. All right, step one is to find their LCM. That is the very first thing you need to do. If they are not equal, you need to find their LCM. Now, you need to pick. You need to pick to find the LCM of the A's, or you need to find the LCM of the B's. It doesn't matter which one you do. If you always want to do the X's, then always do the X's. If you always want to do the Y's, then always do the Y's. It does not matter which one you choose. You just simply need to choose one. So, I am going to choose the X's. All right? So I'm going to look at finding the LCM of 5 and 10. Now, I'm going to utilize the formula. So I'm just simply going to take 5 times 10, and then I'm going to divide it by the thing that goes into 5 and 10. So what can I divide 5 by? That can also divide 10 by. Well, I can divide it by 5. So 5 times 10 is 50. 50 divided by 5 is 10. All right? So what this now means is that any A that is not a 10, okay, so if it's not a 10, I must convert it to a 10. So I'm going to go down here, and I'm going to do my conversions. All right? So here's my conversions. So step one, all right, is LCM and conversions. All right? That is very, very important that you understand. Step one will be finding the LCM and making your conversions. So I go to the top, and I look at my A's, and I go, okay, I got to convert any A that is not an A, or that is not a 10 to a 10. So the first one, okay, I have to convert this first equation. So you don't just get to convert the X. You have to convert the entire equation. So you will take this entire equation, all right, and you will write it out down below. So when I write it, it's 5x plus y equals 9. I look at the second equation. Well, A is a 10. I don't need to convert it. Okay, no need for conversions. I will deal with it later. So here we go. That is this problem here. No need to convert. So what I'm going to do is I'm just going to convert my second one. And the way you convert it is by the multiplication property. So what do you multiply 5 by to make 10? We're trying to turn 5 into a 10. So what do you multiply 5 by so that it's 10? Well, if you don't know that, you just take the 10 and divide it by 5. It will give you the number you need to multiply by, okay? So i.e., what I'm saying to you is that if you didn't know that 5 times 2 is 10, simply divide that by 5 really quick, and that answer will be 2. That will be your multiplier, okay? So what you're going to do now is you're going to multiply the 5 by 2. Well, when you multiply an equation by 2, you don't just get to multiply one thing, because you see this 5x and this y are a group. They're paired together, so they must be together. So if you're going to put a multiple in there, you must group them up, okay, and then put a multiple there. Now, the multiplication property, what does it state? Well, if I multiply one side by 2 that is equal to something else, that other side must also be multiplied by 2. So what I now have is I have a problem that on the left side is the distributive property, and on the right side is just a straight multiplication. So distributive property, I multiply each piece inside by 2. So when I get that, I get, okay, 2 times 5 is 10x, plus 2 times y is 2y. That equals 9 times 2, which is now 18. Now, what this tiny little step, this new step 1, this previous step, what it's going to allow me to do is it's going to allow me to now take this, okay, equation, and I'm going to swap this equation, okay, in this one's place. So I am going to have to rewrite this. So this is a process. You need to make sure you're following along. So step 2 is now I'm rewriting. So I'm taking out the one with the 5, and I'm rewriting this system. And I'm going, okay, the one with the 5 is now 10x plus 2y equals 18. And then what I'm going to do is I'm going to then use the one down there, right? So don't forget this guy. Don't forget the second one because we're rewriting the system. This one gets written again. So I didn't have to convert it, so I just write it as was. Minus 7y equals negative 18. Now, this should now look like something that you've already done before. So the very first time we went through this, this is how we did these problems. So now what I'm saying to you is now we're back at the point. So now we look at this, we go, okay, my a's are now the same. So since my a's are the same, what do I do to make 0? Well, because they're identical, I introduce the subtraction property. So subtract, subtract, subtract. And what I'm left with is that this will turn into 10x minus 10x, I don't write it. I can cross them out if I want to. But 2y minus a negative 7y. So be careful. Two negatives, all right, they're going to convert each other to a positive. So 2y minus negative 7y is really like 2 plus 7. So that is 9y equals 18 minus a negative 18. Does the same thing we just had before. So I'm really adding 18 plus 18, which is 36. So then from here, I have a one-step equation. I solve it, so now we're back into our normal mode of what we did before, so we finish it off the same way we did before. I get y equals 4. Once I have y equals 4, I plug that back into any equation. It does not matter. You can choose a converted equation. You can choose a brand new equation. So I'm going to take that information. I'm going to plug it back into an original problem. And the original problem I'm going to plug it into, me personally, I'm going to choose the first one from the original system, which stated 5x plus y equaled 9. So now wherever I see a y, the beauty is that I can swap out that y and write a 4. So this is 5x plus 4 equals 9. And what I'm left with is a two-step equation. So what I need to know is my inverse operations. Your inverse operations, you have multiplication and division are inverses, and addition and subtraction are inverses. So I have an addition sign, so I'm going to put below it a subtraction sign. And now equality. Equality requires that I must do that to both sides, so I'm minus 4. So this should look familiar. That property right there is the addition of opposites, and the addition of opposites makes 0. So I now have 5x equals, well, 9 minus 4 is 5. And the last step here, I have 5 times x, so I must divide by 5, and I will get x equals 1. Now, our final answer, okay, that we're going to do here is we're going to write this as a coordinate pair. The reason we're going to write it as a coordinate pair, again, is because, all right, we are still finding an intersection point. So the order pair is 1, 4, and that, my friends, is an intersection point. So that problem done. So what I would suggest now is pausing the video and copying all of this work down, all right? So, on to the next one. And the next one is this new problem. And the new problem says 7x minus y equals 19 and 2x minus 3y equals 19. So we ask ourselves questions. Does A1 equal A2? A1 is 7, A2 is 2. They're not equal. Does B1 equal B2? B1 is 1, B2 is 3. They're not equal. So again, the answer is unfortunately, no, they're not equal. So, since, again, I'm going to write this again. So, since neither the A's or B's are equal, we must use the LCM with the multiplication property to convert. All right, so the first time I did this, I said, okay, I'm going to do the x's, right? So notice it doesn't matter whether I choose a's or the x's or the y's, okay? The a's or the b's, it doesn't matter. So generally speaking, what people will look at is they'll look at the numbers first and they'll decide which ones they want to do. In this part, the second part, I will now do the y's. Just to prove to you, it doesn't matter which one you do. I'm now going to do the y's. So here we go. So I'm now looking at the y's. In the LCM, there is no number there, so put a 1 in front so you understand. So you're looking at the LCM of, okay, 1 and 3. And again, I'm going to use the formula. I'm a guy who just likes to use the formula, and the formula is found by doing 1 times 3, and then simply asking yourself, well, what can you divide 1 by that you can also divide 3 by? Well, 1 being the smallest number, you can't divide anything larger than the smallest, so 1. So 1 times 3 is 3, 3 divided by 1 is 3. So the LCM is 3, okay? So now what I must do is I must do my conversion stage, okay? So conversion, so converts, okay? So my converts. So basically I'm going to look at my y's and go, which one of those is not a 3? Well, the second row is already a 3, so I don't need to touch this equation. Don't need to do anything with it. But my first row is a 1, so I must convert this to a 3. So I write that equation down here. 7x minus 1y equals 19. And I must convert that to a 3. So, well, I must use the multiplication property to convert it. Okay, can't use anything else. So what do I multiply 1 by to make it 3? And the answer to that is 3. So what I'm going to do, again, very important here, you must multiply the entire side by 3. So you are creating a distributive property problem. That is important. So I'm going to place my 3 there. Now, I introduced multiplication on the left. Again, the multiplication property states that you must multiply that other side by 3. So again, now it's just a distributive property problem. Distributive property states that you multiply each piece on the interior by 3. So here we go. 3 times 7 is 21x. 3 times negative 1 is negative 3y equals 19 times 3. 19 times 3 is 57. Once I have my conversions, okay, once everything that I need to convert is converted, I will now write my new system. And my new system, again, is going to be my one that I swap out. So I'm switching out this equation for this one down here simply because this y was not 3, but this one does have a 3. So all I'm going to do is swap them out. So I'm going to write my system again, and here it goes. System is, and you don't have to write this little squiggly thing, by the way. So if you don't want to write the squiggly, you don't have to at this point, okay? You can go 21x minus 3y equals 57. So swapped out the first row for my converted row, and then I get 2x minus 3y equals 19. So at this point, what I'm going to do is I'm going to look at my y's and I go, okay, what am I doing with them? Well, in this case, all right, negative 3 and negative 3 are the same. So the property that I have to use here is going to be the subtraction property. So be very careful. You must use the subtraction property in this case because they're both negative. So if the same, we always subtract, subtract, subtract. So here we go. 21 minus 2 is 19x. The negative 3 minus the negative, right? Subtraction of equals makes 0, so I just cross them out. Equals 57 minus 19 is 38. And then from here, my last step is to divide both sides by 19 to break apart the multiplication. Divide by 19. So please note, I'm always dividing by the thing that's next to the x. So x now equals 2. Once I have x equals 2, what I simply do is I go back to any equation. Doesn't matter. You can choose the converted equation if you want. You can choose any equation you want. So in this case, I'm going to just choose the second equation because I see that I have x and multiplying it by 2 is easier than 7, right? So that's my rationale for it. You don't need to use the same rationale, but you can pick any equation. So I'm going to do this, and I will do 2x minus 3y equals 19. So now anywhere I see an x, so here's an x, I get to swap out just that variable and place a 2 in its place. So 2 times, so 2 minus 3y equals 19. Simplify this, which becomes 4, minus 3y equals 19. And from here, I like to, because it's a positive, right? I like to put the plus sign in front of it because now all I'm looking at is how do I make a positive 4 go away? And that positive 4 goes away by putting its opposite with it, right? So 4 and negative 4 make 0. 19 minus 4, right? Because if I do minus here, I got to do it over here. So boom, boom. So I get, now, be very careful. This is a negative 3. You must drop that negative down with that y. Do not drop it off. It doesn't get to go away. So negative 3y is now equivalent to 15. Last step, divide by the thing with the variable, which is negative 3, divide by negative 3, and I will get y equals negative 5. So my answer to this one is negative 5. So the final answer is going to be 2 comma negative 5. That is my point of intersection. Okay, so we're on to another problem. So the next problem here is going to be an error analysis. So what we need to do is we need to go find the error, and then we need to correct it. Okay? So the first things first that they notice in step 1, let's just go through their work. Step 1, we know step 1 is to verify whether the A1s equal the A2, and if they don't, we create the LCM. So what we notice here is they know that A1 does not equal A2 and B1 does not equal B2. Awesome. So I look back up here. They are correct. They do not equal each other. So then they say LCM of 4 and 1 is 1 times 4. And the greatest thing that goes into it is 1. This is all true. So 1 times 4 divided by 1 is 4. So there's no mistake here. All right. So then I go down to here. So notice the process I'm doing. So I'm going to stay for a second here, right? So why are they multiplying by 4? All right. Because the only equation they need to convert was the second one. Notice the first one has a 4. No need to convert the first one. So I'm converting the second one. And we go through. All right. And we write 4 times x minus 4 times 5. So 4 times x, is that 4x? Absolutely. How about 4, okay, times that 5? All right. Okay, 4 times that 5, all right, makes, does it make negative 5? Oh, 4 times negative 5. Oh, wait a minute. 4 times negative 5 is not negative 5. That's actually negative 20. I found a mistake. That's all I need to find. One mistake. I found it. I'm done. Okay. The question is what was the mistake and in what step? It is step 1. They distributed improperly. Okay, so since they distributed improperly, what I'm going to do is go fix their corrections, and then I will continue on from there. So the correction comes into place here at this step. So this is the step I have to correct. After I correct this step, I'm actually going to ignore, okay, I'm going to ignore everything else. I don't care about any of the other steps. Once you make one mistake in a math problem, the rest is going to be wrong. So here is my mistake. The LCM was right, they just didn't multiply it correctly. So I'm going to start from step 1, paying attention to my distributive property, and then I'm going to finish it off all the way through. So here we go. Okay, so writing it from here. So we had that we knew it was a 4, so I'm going to put the 4 there. So 4, and I should be multiplying this by the x minus 5y, parenthesis, equals, so that 13 now also has to be multiplied by 4, okay? So here we go. 4 times x. Yep, they had it right the first time, 4x. 4 times negative 5 is negative 20y, all right? And then the 13 times the 4 is actually 52, all right? So there we go. I now have my piece that needs to be swapped out. So now all I simply do is go back to my original system. My original system was this 4x plus 15y equals 17, so that one's okay. All right, so 4x plus 15y equals 17. So plus 15y equals 17. That was the first one. That one was okay. All right, and you don't have to write the squiggly part. Okay, but the second equation that we just converted was not okay. So we are going to write the new converted piece, which is a 4x minus a 20y equals 52. And from here, what I'm going to do is finish this off. So 4x and 4x are the same, so identicals, equals, we subtract. So subtract, subtract. And now I continue on through this problem. So here we go. 4x minus 4x, 0, crossing it out. 15 minus negative 20 is 35y equals 17 minus 52 is negative 35. So the last step here is divide by 35, and I get y equals negative 1. Now, once I have y equals negative 1, again, it doesn't matter which equation I plug it into. What I do now is just simply plug it in. So here we go. I'm going to take that information, choosing the equation. I'm just going to choose the original x minus 5y equals 13. Okay, so from here, what you're going to do is now that you have the y being equivalent to negative 1, what you're going to do is the same where you see a y. So here I see a y. Now, important thing here is I don't get to replace the 5. All right, it's just the y variable gets replaced. The 5 has to stay put, the y has to stay there. So here we go. I get x minus 5 times negative 1 equals 13. So I now get x negative 5 times negative 1 is a positive 5 equals 13. So now we use the addition property of opposites. So if I have a positive, I need a negative. So negative on both sides. Those are 0. I'm left with x equaling 8. So my final answer to this problem is going to be 8, negative 1. And again, my solution represents the point of intersection. All right, so on to our last two examples. So our last two examples, here they are. So we're going to go through these a little bit quicker, so here we go. So first things first, what I need to look at is, are the A's the same or the B's the same? And in this case, again, neither of them are the same. So this is 8 and 6, this is 4 and 17. So now what I'm going to look at is which ones do I want to change? So this is where knowing your multiples makes life a little bit easier if you don't know your times tables, right? So what I look at is, I'm looking at, is there a relationship between 6 and 8? So before I just jump into LCM like I did before, I want to see 6 and 8, is there a relationship? And the answer is no, there's no relationship. 6 is not and 8 are not related by multiples. But however, when I look at the y's, I have 14 and 7. So how are they related? Well, 7, okay, or 14 is just double of 7. So what that's important is that that's an easy way of doing the mental math of knowing your LCM. Otherwise, okay, what you want to look at is the LCM of both of these. So you have that formula. So the LCM, I would take LCM, and I'm going to look at 8 and 6, okay, and following that formula, we do 8 times 6 and divide that by what's the largest number that goes in 8 and 6, and that is 2. So 8 times 6 is 48 divided by 2 equals 24. Now, notice, none of those numbers are 24. So what I'm going to do is, since none of them are 24 already, I'm just going to go over to the y's and go, okay, LCM of 7 and 14, all right? So again, what we're going to do is we're just going to take 7 times 14, so 7 times 14, and I'm going to ask myself what number goes in the 7 that also goes in the 14, and that is 7, okay? So 7 times 14 is 98, okay? And then you're going to divide that by 7, all right? And when you divide that by 7, you get 14. Now that's a nice one because guess what? One of my numbers is already 14. So the reason, okay, I'm going to change the y's as opposed to the x's, all right, is because the LCM of these two is 24. Neither of them are 24. The LCM of these two is 14. This one's already 14, which means I don't have to change it. This one is the only one I have to change. So instead of having to change both, I only got to change one. So here we go. So we take that second equation, we rewrite it. So we're going to convert now. So here we go. We go 6x plus 7y equals 10, and we're going to convert. So I need to change that 7 into a 14. So how do I change this 7 into a 14? You multiply it by 2. So I go times 2. So if I multiply by 2 on the left, I must multiply by 2 on the right. So the left-hand side has a distributive property problem. So this becomes 12x plus 14y equals 20. And now I have an equation that has both the b's are the same. So b is 14 in the first one, b is 14 in the second one. So I rewrite my system over here. So here we go. I go 8x plus 14y equals 4. And then I write the 12x plus 14y equals 20. And now I observe, what should I do? Should I add or subtract them? Well, they're both positive, so I do subtraction. Subtraction is when you subtract the same. So I'm doing 8 minus 12x minus minus. So here we go, working through my steps. 8 minus 12x is negative 4x. 14 minus 14 is 0. 4 minus 20 is negative 16. My last step, divide by negative 4, divide by negative 4, I get x equals 4. Once I have x equals 4, again, I'm going to take that and I'm going to plug it back into one of the equations. And I'll just choose the original equation, and I will choose the second one there, right? The one that I altered in the first place. I'll just use the original. So 6x plus 7y equals 10. Wherever I see an x, I now place a 4. So 6 times 4 plus 7y equals 10. So this is 24 plus 7y equals 10. I have a positive 4, so I must place a negative 24 underneath there. So that becomes 0 minus 24, and I get 7y equals negative 14. Divide by 7, y equals negative 2. So my final answer is 4, negative 2. Again, that is the point of intersection. So on to the very last one, all right, that we're going to deal with today is B. So B, so what we're going to do is we're going to look at these again. We're going to go, okay, look at my A's. So my A's are right here. My A's go with the X's. My B's go with here. So again, I'm just going to do some mental math, all right? So I'm going to say, can 3 be turned into 9? And the answer to that is yes. Well, if I can turn this one into that one, then I'm going to do it, right? Notice they're not the same, but I can turn this one into that one. So therefore, I'm just going to change this equation. So now, I'm going to show this one, all right? I'm going to convert it. So here we go. I'm doing negative 3x plus 7y equals negative 16. And what I'm going to do is I'm going to take this information and I'm going to change it. Well, how do I change 3 into 9? You multiply it by 3. So I must multiply the other side by 3. And what I'm left with now is 3 times negative 3 using distributive property is negative 9x. 3 times 7 is plus 21y equals, and negative 16 times 3 is negative 48. So now I have the equation that I can pair with this one. So I make my system out of these two. And I get 9x minus 5y equals 16, and negative 9x plus 21y equals negative 48. And then from here, all I'm simply going to do is, because now the 9 and the negative 9 are opposites, so I'm adding. So 9 and negative 9, 0. Negative 5 plus 21 is 16y equals 16 plus negative 48 is negative 32. Divide by 16. I get y equals negative 2. Once I have y being negative 2, I plug it back into an equation. So what I'm going to do is I'm just going to do the first equation that I originally had. So I'm going to take this and I'm going to plug it into negative 3x plus 7y equals negative 16. Wherever I see a y, I'm replacing it with negative 2. So negative 3x plus 7 times negative 2 equals negative 16. Negative 3x minus 14 equals negative 16. I'm going to add 14 to both sides. Add 14 to both sides. And I get, move my work over here. Okay, and I get negative 3x equals negative 2. Divide by negative 3, divide by negative 3, and I get x equals, and in this case, I take a look at it and I get 2/3. It's okay that I got something a little weird. Okay, it's just a fraction. I understand that it doesn't go in evenly, but a negative over negative becomes positive, and I get 2/3. So the coordinate pair here that I have is going to be negative 2/3, okay, is going to be 2/3, comma, negative 2. And that's it for that video. Oh.